Hi, everybody, and thanks for attending today's webinar, Modernize Applications in Azure with Chef Habitat. Manage your critical cloud applications at scale. My name is Erin, and I'm on the marketing team here at Chef, and I'm happy to introduce today's speakers on this webinar as James Massardo, Lead Customer Architect here at Chef, and Lee Oommen, MTC Architect at Microsoft. So before I turn it over to these two, I have a couple housekeeping items to cover. If you have any questions, you can submit them in the Q&A section at any time, and we will be answering questions around the end of the presentation. For the best viewing experience, we recommend closing any additional programs or browser sessions running in the background, as webinars are bandwidth intensive. And finally, this webinar is being recorded, and an on-demand version of the presentation will be available by tomorrow. So for those of you just joining, welcome to today's presentation, Modernize Applications in Azure with Chef Habitat. Manage your critical cloud applications at scale. Let's go ahead and get started. James, over to you.
Hey, thanks, Erin. As Erin mentioned, my name is James Massardo. I'm a lead customer architect at Chef. And we've got Lee from Microsoft on here as well to help us with some of the Azure DevOps side. So let's take a look at our agenda today. So we'll start by looking at, like, what do we mean by modernizing applications? Like, what does that entail? What do we do? Like, why do we need this thing? We'll identify, like, what our key outcome is. And once we know what we're trying to do, and we know like why we're doing it, we'll look at one pattern to accomplish these. So in this case, to accomplish our outcome, we're going to use Chef Habitat for some application automation components, and we'll use Azure DevOps to handle some of the process automation components for this. The way that we're going to go through this, we'll do kind of an overview of each tool. We're going to take a look at Habitat, and we're going to take a look at some components in Azure DevOps, and then we're going to put them together to see our actual outcome come out. And as Erin mentioned, if you have questions, please ask them. If it's something that's really relevant, we'll dive into it. If not, we'll hold it till the end. All right. So when we look at the traditional application pattern, we build infrastructure, and then we put operating system, and we put libraries, and another group adds this, and another group adds that, and then finally at the very end we put the application on top. And in a lot of cases, this fails or has problems. Someone works on it, generally they get it up and running, and then they don't document it. So now we have this kind of unknown config running out in the wild, and it's supporting the app that makes us money, right? And the app's what we really care about, but we build all of this other stuff before we get to the app, the actual application. Building this, we end up with this kind of unknown that nobody wants to touch because they don't want to break it. So it just kind of sits around, and like that's how most of us end up with some sort of tech debt. Somebody builds something, they don't document it, it just kind of gets, that can just kind of gets kicked down the road. And these apps, in most cases, they tend to be legacy or line of business apps that still have value to the business and provide important functionality, but they're either really, really difficult to rewrite, or they provide business value, but they don't provide enough to justify doing an entire rewrite. So, that kind of leaves us in a tough spot. We have applications that don't have any life cycle. They don't have any way of standardized process for releasing and managing it. We don't have good process for releasing changes, and we're kind of stuck with these apps where they are, meaning there are obstructions to migrating to modern platforms, right? If we don't know how the app's set up and we don't know a lot about it, it's really, really difficult to take that app and run it in, say, a container, or moving to Kubernetes, or moving to the cloud. So that's where Habitat comes in. So Habitat enables application teams to define, package, and deliver any application in any environment. And when we say any application, we're basically meaning if you have the source code for it, if you have the install files, if you have the zip file that has all the stuff in it, if you have the folder that has all the files in it, we take and we codify the process for how that application is delivered. And now any environment that meets our needs can run that application. So that's how we can take an existing application, and essentially what we do is we wrap some automation love around it, and now we can take that payload and we can run it somewhere else. So what does that entail? You know, so we have our application, we have our build instructions, which could be, how do I go get my, like, where is the source files? How do I go get them? What commands do I need to run to build them? Are there any changes that we need to make to them? Configuration instructions, as in, you know, how do I set my config files up? If I'm deploying a website, how do I tell what port to run on? The relationships and dependencies, like what things does my app need? What do I need to run? Do I need database connection strings? Do I need a particular version of a dependency? And then the last piece to kind of our puzzle here is the runtime instructions, which is like, how do I start my application? How do I stop it? You know, how do I health check it? Those sorts of things. So when we take this and we turn it upside down, right, we look at the application as being the important thing, right? The application is what makes us money. That's the thing that we really care about. So we want to focus on it being the most important thing, and then putting all the other pieces of like how that app needs to run together so we can get it deployed. So as we've collected up some of this data, you know, we've got our instructions, we know our dependencies. How do we start putting this stuff together? So with Habitat, we have the plan file, which like I call the plan file, like that's the codification of tribal knowledge. Like, when you have an application, you have this, like, different people have different bits of knowledge about how to make it run, but it's not written down anywhere. So the plan file gives us a single place to put all of that stuff. All of our build instructions, all of our fetching, all of those sorts of things. So when we take that and we run a build, now Habitat generates an artifact for us. And this immutable artifact is hashed and versioned down to a specific timestamp. So when we deploy it, we know that as we take and deploy it through our different environments, we know that the code that's being deployed is the exact same code across each one. So when we run it, we can deploy that to, you know, we can deploy it to bare metal, we can deploy it to a container, a VM. You know, if you're using something like Packer to produce your images, there are ways to pull that straight in. So if you'll notice, it looks like this is kind of two layers of the process, but there's actually a little bit of separation here. And what this does is it gives us a little bit of decoupling in the process. So app owners or developers can move at their own pace. So they can generate build artifacts that have all of the necessary instructions. So whenever the operations teams go to deploy it, they know what the requirements are. They've got it all codified, and now they can run that application, in a place that either better utilizes available resources or in places where they can reduce costs, thus making them more efficient. So I mentioned the plan file. The second piece that we'll look at today are called the lifecycle hooks, or the available hooks, where these are the things that we tell Hab, like, this is how to start the application, this is how to stop it, this is what happens if you do a reload, if you need to restart the service, this is how you health check it, that sort of thing. And within these, they give us a lot of capability. We can do upgrades, which is one of the things that we'll see. There's sequencing, there's management. There's a lot of pieces that go into it. There's an immense amount of configuration management that we can do within the application as far as configuration, templating, and that sort of thing. We'll take a look at a small piece of that. But the main things when we start are we want the plan file to have all of our relevant data for our application, and we want the minimum number of hooks. In most cases, is just the run hook that tells us how to start and stop the application. So those are the things that we'll look at when we actually dive into a demo here in a couple of minutes. So this is an example of one customer who took a legacy application, a very odd application written in Delphi way back in the late 90s that still provides a ton of business value to them, but it took quite a bit of man hours to actually do the upgrades, and they weren't super successful with them. With changing that app deployment model over to Hab, where they modernized that app, basically they wrapped that love around it. Now they can deploy it in roughly 10 seconds. And since they can test it and they have a very high reassurance that it's going to work, now when they roll to their environments, they have very, very little failure. So that kind of covers like the brief overview of Hab. So like we talked about, like our problem is we have this application that we need to modernize, meaning we need to wrap modern process around it. So the habitat pieces give us the application pieces that we're looking at. Now let's go ahead and take a look at using Azure DevOps to modernize some of the process around it. And Lee from Microsoft is going to take us on a quick tour of some of the Azure DevOps features.
Hey, thank you, James. So now that we have a peek into how Habitat is used to handle the application automation, let's look at how Azure DevOps is going to handle the process component of Habitat. Let me first start by saying Azure DevOps is not a product. It is really a collection of different DevOps components put together. And you have the freedom to choose which component will be best suited for your application development scenario. As we are talking about app modernization, we all know that for any software project, we require at least minimum 3 components, right? So we start with a project management tool, a place where we can gather the requirements, break it up into various tasks, assign people to those tasks, and monitor those tasks. So it all starts with a project management tool. And for that, we have Azure Boards. And then with that going on, a source control or a code version control tool is required. So when multiple developers work on the same project, they will save their code to a central place called repository, right? This tool will maintain who made and what changes they made, and it should also maintain the history of code changes. So for this purpose, we have Azure repos. So with the project management tool and a repo in place, the next to have is a build and deployment tool. Creating a software project is like putting together a puzzle where every developer solves one or more pieces of the puzzle. And in the end, all these pieces are combined and made sure it works together. And then build it as one software unit so that it can be deployed to a server, which is going to serve that software to its end users. So at a minimum, you need 3 components. And for the build and deployment tool, we have Azure pipelines. And obviously, we do have Azure test plans, which is used to build and ship efficient test plan for your code. And again, artifacts. We are not going to touch on test plans or Azure artifacts right now. I would like to quickly jump into a demo of how to set up Azure. How to set up how to set up Azure demo. Give me a second, guys. All right. So I'm hoping you're able to see my screen.
Yeah, I can see it.
Okay, great. So we talked about Azure boards. So when I log into Azure DevOps, this is my launch screen. Since I am an experienced DevOps engineer, I have lots of projects going on. So in my organization, I always start with a new project. Okay, and you get to decide what should be the access for this project. It could be for the whole enterprise, or it could be a private repository or a project, because I want to invite people into this project. I want to have security for my project. So I start with defining that, which means nobody has access to my project. I need to invite people into my project. So the next thing is to determine on a version control that you're going to use for your software project. There are two options within GitHub.
Hey, Lee, I think you're sharing the wrong screen, perhaps.
Right.
Or it's a different.
Are you seeing my DevOps screen?
Just seeing your background or your desktop.
Okay, guys, give me a second. Apologize for the confusion. Are you able to see my screen now?
I don't think you're sharing anything. Oh, there we go.
Okay, sorry about that.
Still just your desktop though.
Sorry, apologize for the confusion. I'm sure now you can see my screen. Can you?
Nope, we don't have anything. There we go.
Okay. So I'm going to create a project quickly, guys. And here I'm going to select the access control I want to this project. And then we are going to decide what kind of Git version are we going to use. Whether it's going to be Team Foundation, this is going to be our Azure on-premises version of source control. And then you need to decide what kind of software development framework you want to use. We are going to go with Scrum because Scrum is a very popular framework. What Scrum does is it will give you the option to define your project into multiple phases. With iterations, you need to go and define a lot of different settings for your project once you start that, right? So let's go and look at what are those minimum configurations that need to have in place. I just created a new project, and there is only one team member here. I can go and start adding team members from inside my organization or from outside the organization. So this is from my organization. This is already added. I'm going to use a user from outside. You should be able to invite people who are not in your directory to this project. Okay, this is how you start building up your team members. Once you have your team members, you need to start defining what kind of permissions do they have. And these are the basic built-in roles and rolled up as groups into Azure DevOps. So based on the function of that particular team member, you're going to start adding members to that group here, right? Once you do that, you start configuring your notifications. And this is where you define who gets notified on the various process of your software development stages. And there are many different things that you need to configure here. For example, in a big project, you need to start creating service connections to the different to the different products that you're working with. In this case, I'm going to work with Chef Habitat. So I need to establish a connection, a service connection with Chef. And this is where I do all those. When I want to work with Azure, I create a connection object with Azure Resource Manager and go ahead and define all the necessary requirements to satisfy that connection. Once I do all that, ideally speaking, as a developer, when I log into my session, I should see a dashboard, something similar to this. I get a quick view of what is done, what needs to be done, what are assigned to me, how does a project look like, and all that. All this is possible only if you go to Azure boards and start looking at defining your backlogs, right? This is where everything starts. You start defining your project into epics. This is an overarching project, and every epic will have many different feature releases, and each of those feature releases will have many stories to work on. So typically a story will take few weeks, and within each story, you're going to define your tasks. And we need to do all these things from day one. Otherwise, you're going to lose that end-to-end visibility into your project. So once you do that, and because we are doing Scrum, we can do a sprint, and this is where you're going to see all your work items. You're going to see what stage are they. Some are in progress, some are done. So there's an item here to do. So I can start with this. I can do my coding, and once I'm done, I can come and move it to my sprints, right? So this will all help when your project manager go to their Kanban board. This is like a Kanban board, right? Every project will get a default board, and once you define this default board and all those work items, you should go and define multiple dashboards, right? There should be a dashboard for each of your developers, a certain dashboards to have a view of your software. So that's what you overall achieve with Azure boards, right? Everything, this is where everything comes together. You are collecting all the requirements, and you're definitely assigning those requirements to your team members. You're controlling on what the team members can do, and everybody comes to the dashboard for their work, right? So once you have these boards going on, the next thing what we wanted to cover would be repos. So basically, with any software, when multiple developers work on the same project, like we said, they will save their code to a central place. And that's the repository that we are seeing here. There aren't any files here. I just initialized this repository. And developers will have to create and push code to the central server from their desktop or from their IDE. So this is where Git comes into picture. If not already, you need to start looking into Git, because previously source control used to be in this one central repository, either the cloud or your on-premises server. And all developers will create the code and maintain it in this repository. And central repository will know of who made of what changes. But over a period of time, people felt like having their own local version control in addition to the central repository. So the local version control is what we call as Git. So Git maintains a history of changes locally on the developer's machine and syncs that change to Azure DevOps, so that Azure DevOps can use it to manage who made what changes remotely in the cloud, right? So Git is going to be a very powerful tooling for your DevOps to be successful. So in Azure repos, once you have your repo created, you start assigning permissions to this repo, right? This is where you need to go to your branches and look at the available settings and start assigning people to this repo, and you can decide what should happen on those branches, right? And we are providing you with a lot of best practice policies here that you can see under branch policies. So it is a best practice to have a minimum number of reviewers for your code. And all that you get to define here. There are many different options that'll prevent you from allowing requesters to approve their own changes, for example, right? And likewise, you need to make sure that your work items, that the code that you're going to check in is linked to a work item. This could be a best practice. If you don't do these best practice controls from the beginning, after a period of time, you're going to come across problems. Same thing when you're doing coding as a group, when you're doing pull requests and such, your approver are going to give you some comments on what needs to be done in order for him to approve that request. So we can have a check in place to make sure all that is done. And the most common thing when you work with Git and a central repository is to really manage the merge conflicts, right? You work on a local version of your code. At some point, you're going to upload that to the central repository. And some other developer is going to download that code, and he's going to add his piece to that puzzle. Which means that when you upload your code next time, there is going to be a conflict. And there are many different ways to resolve those conflicts. And this is where you come and configure all those requirements, right? So that gives us a baseline on what needs to be done in your Azure repo. And James is going to really go through some of the stuff that Habitat or his application how that is going to function given a repository. All right. So with that, I want to quickly talk about pipelines now. So pipeline is basically for us to take our code from production. Sorry, pipeline is basically going to help us build the code that the developers are going to upload to the Azure repo. So always there's going to be that continuous build happening, right? You need to create a pipeline to tackle the build. And there are two ways to create it. Either you could use the classic editor, which I'm going to show just so that it is going to be comfortable for all. But today's best practice is to really create your code, your pipeline, using YAML files. And James is going to talk about all that in a while. But I'm going to quickly show you the old editor. This is very easy. You just come here and decide where are you pulling your code from? Where does the code reside? And these are the different Git repositories out there. And once you configure that, it'll automatically, once you configure the source of your code and the type of application you're trying to build, it's going to automatically set up all the tasks that are required in order to build that code. And this is how you set up a simple build pipeline. And once you build the pipeline, the next thing is to really release that pipeline into production. And how we do that is create a pipeline using different stages. So I'm just going to quickly show you on what it should look like. You could have a dev stage and define tasks in that stage. And this task could be, in this example, it could be installing, it could be modernizing the application using Habitat. So I just go and look at all the Habitat extensions that are available for my build process. I go and configure them, and once I have configured them, I have the capability now to, once I'm ready and comfortable with all the tasks that needs to be part of that pipeline to a particular environment, I should be able to clone that and call this prod and make sure I configure some deployment gates and some other controls so that your pipeline is secured. And you can also make sure that in the production, you don't want to deploy any application code to the environment if that environment is unhealthy. So this is where you define all the different controls that you would want on that pipeline. I'm just configuring here for the pipeline to see if the destination, if the Azure environment is really compliant, so that I can proceed with my deployment. So that was just a simple example to show you how to connect, how to take advantage of the integration between Azure and Azure DevOps, right? You're deploying your application to Azure, but before you deploy your application to Azure, you want to make sure that that environment is healthy and that environment is compliant. And we give you gates for that. We also give you deployment approvals. You should be able to define who is going to approve that deployment once it is ready, once it is ready for deployment. So Azure DevOps is very crucial for your application development process because it is number one, it gives you the option to choose what are the different components that you want to use in your products, in your development scenario. Like we were explaining, you always need to have boards, because without boards, you will not have that visibility into your project. And with repos, you're going to have policies in place to protect the repo. You will implement pull requests to make sure that nobody fiddles with the master branch. And once all that code is secured and built, you need to focus on pipelines. And with pipelines, you have build pipelines and release pipelines, and then you can go in and configure a bunch of things to make that pipeline successful. So these are the process components that one would need to really be successful with application development, and especially with the Chef Habitat. I hope I covered a lot of things quickly to give you an idea of what those different components are and how they are going to work together. And that being said, I think it is time for the Habitat demo that will bring everything together. James?
Yeah, thanks, Lee. All right, so let's take a look at our application. So as Lee mentioned, we've got our code stored in a repo within Azure DevOps, and we're also using the pipeline components within this. So in this case, I'm lucky that I have all of the source code, so I'm just using it. However, Habitat, as I mentioned earlier, can work with COTS applications. It can work with complex applications. There's a bunch of different things that we can do with it. In my case, I've got the source files for a .NET Core application that we're going to deploy onto a Windows system. It also works with even really complex applications like SQL Server. Here's an example of one of the core plans that we have for MS SQL Server that's capable of doing availability groups and some HA components, things like that. So back to our simple example. As I mentioned, there's two primary things that we want to focus on. The first is the plan file, and the plan file is the piece where we put all of our information. So in this case, we have some metadata. We have our name, and we have our name. The origin is basically like the owner, versions, maintainers. Then we have our dependencies. So if we were to do this by hand, we would have to go write some code to go fetch the .NET Core install from some repository somewhere, and then automate the install, and then check and make sure all the bits are there. Hab does all of that for us. So we have a single line. We say we need .NET Core, .NET ASP Core. You'll notice that this is starts with a core on the front of it. That's what we call a core plan. So Chef provides, I think there's 700 core plans that are available that you can just directly consume that cover a number of dependencies and libraries across both Linux and Windows. Since there's one that we need, we're going to say we just depend on it. We need the SDK to do the build. So we're going to say we need the SDK right here for our package build. Then we're going to give it the commands to do the install or to do the unpack. Then we're going to give it the build. So since it's .NET, we're just doing a pretty simple .NET build. Then we're going to copy those files out to a place where Habitat knows about them. So this is a very simple example of that codification of tribal knowledge that I was talking about earlier. So the other piece is the lifecycle hooks. So here we have a hook. Again, if we were doing this by hand from scratch, it would take a fairly good bit of coding for us to build a script that would make sure all of our stuff is there, make sure we've got all of our files and folders in the right spot, go find anything that we may need, do any kind of variables and configuration and things. Since Hab handles pretty much all of that for us, the command for us to start our application is really just a single PowerShell commandlet. There are a number of helpers that are provided. So in this case, we know we want to run, we're just going to run the .NET server. So instead of us having to go do any queries or checks or anything, we can use the existing helpers and just say, you know, when this runs, go get the package path for, you know, core.NET ASP core, and then run the, you know, append that in. I mentioned that there's a really powerful configuration templating engine built into Habitat. In this example, we're only using one piece of it, or we're using it, but we're only doing it for one piece. So we're specifying a config port. We can provide those in the defaults. So we start off with saying defaults, and then we can override them at runtime, either by providing an additional override toml locally, or by running some commands against the machine and provide it with additional configuration information. So let's take a look at what an actual change would look like. We already have our application and source code. We have our plan files and our hooks. So we're going to come in here and just make a real simple change just for the demo. So we're going to change the background. In case you're wondering what this application looks like, this is what it is. It's one of the ASP.NET demos, and it just generates some random data for us. So we've got this red banner here, and our folks have said that it should be blue. So we're going to come in here and make a quick change. I'm just going to go ahead and edit it. As Lee mentioned earlier, you know, source code management's really important, especially when you start working in teams. So as you're doing this with a group, make sure that you talk through your branching strategies and how your process should go. You know, the general, I'm going to create a branch, I'm going to make my change and create a pull request. That type of process is really helpful, and it helps track all of your changes and everything. Lee also mentioned the work items. So if we were doing this as part of a project or a sprint, we could come in here and we could assign or we could link this change to a particular issue or work item that we may be working on. So we'll go ahead and link that up, commit it to master, because why not? So let's kick this off. So it committed it. Now if we look at our pipeline, we can see our pipeline's already running. And we have three primary stages in our pipeline. We have a build, which is going to take our source code and all of our components. Habitat's going to generate the artifact that we want. And since we're talking about modernizing applications, most people are trying to get to some more modern technologies like Kubernetes or containerization, things like that. So what we can do is Habitat, we're already making a payload that has all of our code and has all of the essence of our application. So it's a relatively simple command to export that from Habitat into a dedicated Docker container. So we can take the same code, like we mentioned earlier, and we can make it where it can run anywhere that meets our dependencies. So as we're trying to move technologies, if operations is moving toward a containerization strategy, we can generate payloads that work on both their VMs and that work on their containers, and it's the exact same code base that we're producing from. So we don't have to have different work streams to work in those different technologies. So while this is running, let's go take a look at what this actually looks like. Lee mentioned the YAML pipelines. So we'll take a look at these. I know some people, when they get started with these, they're like, this is a lot of code. So Chef, we provide a set of examples. Actually, you can go download this particular example, and we'll share this link as well. You can go download this exact example that I'm running, and you can run it yourself. As you're going through these, there's an option to load the settings up for them. So over here on the right, it looks like a lot. Really, all we're doing is specifying the origin. So this origin is being stored as a service connection, as Lee was showing earlier. We do that so we don't have to store any secrets directly in our pipeline, right? We want all our secrets to be protected. So this gives us the option to store all of that separately and just refer to it. So there's the couple of steps. You know, the ones here that have Habitat in the name, these are ones that are part of the extension. You can also find them if you wanted to add one to an existing pipeline. You can find them under the Habitat tasks. And then you can fill them in and then add them straight over into your YAML. So like, don't feel like you have to write the YAML from scratch. Like I don't, I use the task generator and then I tweak them to fit what I need. So we're doing a build, and then we're doing the package upload right here. So this is what's uploading it to Builder, which Builder is our SaaS service for Habitat. So your clients, whenever you load Habitat on them, you tell them what service to load, and then you tell it where to go get that payload from. So if you want to run something from the SaaS builder, then it's already configured to talk to that. You tell it the origin and package name, and it automatically downloads it and installs it. If you have applications that need to be more heavily protected, you can also run the builder service on-prem in your own environments, and you can pull directly from there if you have air gap environment or regulatory requirements. Then, like I mentioned, we're also doing an export. So right here, we're just exporting it out, and it's a single command, app package export. Then we're uploading it to ACR, and then if the ops folks wanna, as they wanna move toward containers, like it's there for them to use. So let's go take a look at this and see if it's finished. It's probably still uploading to generating the Docker image. But since we already published it and our dev node automatically listens, when we refresh this, we should get a blue banner. Yeah, so here's our blue banner. So when this gets finished exporting, it'll go ahead and move on, and then we're using the existing approvals that are in the environments in Azure DevOps. So as this finishes up, when it goes to the deploy stage, it'll prompt for approval, which generally we want some sort of approval. You could add in additional checks if you wanted. You could add in inspect tests to see, you know, does it meet what your requirements are. One other piece, as we start looking at moving over, as we start moving, modernizing those applications, when they're running in the old way, we have very little knowledge about them. Like we know the app's running over there, but we really don't know much about it. and we don't have a really good way to track what versions are running between dev stage prod, or there may not even be a dev stage prod. So Automate, which is our primary visibility observability platform, gives us that visibility. We have our 3 nodes, dev stage and prod, all reporting in, and now we can see that our dev system is running this particular build of them and the other 2 are not. So as our pipeline finishes up and we get our prompt, we'll review this change and go on. We already looked at our dev system. As this runs, within a minute or 2, we'll see this node roll over to the new version, and then we'll be able to confirm that these 2 versions match. Since we know these 2 versions match and we see what we expect, then we can go ahead and release it to prod. Cool, so what questions can we answer?
All right. So yeah, if you do have a question, just feel free to put it in the little Q&A app. Let's start with a question here. It is just, how can somebody try all of this out?
Sure. So Azure DevOps, you can go to dev.azure.com and you can try it out. I think I'm running on one of the free plans. So everything that I'm doing, you should be able to do in a free plan. If you want to try Habitat, you can go to habitat.sh. And we have a learn section that has a set of examples. And then we also have Learn Chef Rally that can help walk you through some of them. For the pipeline bits, as I mentioned earlier, we have example pipelines that are very generic, that should be like 99% direct consumable. And we'll share these links so y'all have them. What other questions can we answer?
Yeah, if you have a question, just put it in either the chat or the Q&A, and we can answer those live right now. Another one here, how can we see all of the dependencies?
Yeah, sure. So I mentioned in the plan file, right here, we declare our dependencies. But what does that actually depend on? In this particular example, it doesn't depend on a whole lot. Let's take a look at one that does have some transitive dependencies. So in this case, this is Wildfly, which basically like the open source JBoss server, the Java service. So in our package dependencies, we can see that we depend on core JDK8 and core curl. So we know that there's other stuff behind this. We can go look that up in Builder, and Builder will give us like, here's my Java application that depends on Wildfly, and then Wildfly has all of these dependencies. So we're down to the timestamp, so we can see the origin, the package name. Let's see if I can get one of these to highlight. Origin, the package name, here's the specific version, and then the timestamp of when the actual package was built. So you can go all the way back to the specific build of that package. I mentioned the core plans. Let's see how many there are. Oh, I'm not going to count them. There's a whole bunch. Like I said, I think there's at least 700 that are in here for all different libraries and runtimes and applications and things like that. So like there's a one for Git. If you needed to fetch some stuff from Git, you could just add a dependency to Git. You wouldn't have to worry about installing it. Hab would go get it for you. So let's see here. Do we have any other questions?
It doesn't look like we have any right now, so.
Cool. Yeah, so we can see our stage node has rolled over to the new version, and now our dev and stage are both running the exact same version, and they're both healthy. So cool. Well, that's the end of it for me. If anybody has any questions, feel free to reach out. You can get us directly. You can find me on Twitter, anything like that.
It looks like we have one more that snuck in before signing off here. I think it's a good question. What's the biggest impediment to adopting Habitat?
So I would say there's two things that we see people struggle with up front. One is, the first is the fact that Habitat is considerably different in approach. In general, most people look at like, oh, well, we're going to build this data center and then we're going to build these servers and that sort of thing. With Habitat, it's totally the other way around. And so that takes a little bit for everybody to get their head wrapped around. Then the other thing tends to be finding the right information about the application. Like all of that knowledge, like going and tracking all of that down. Folks that have good build sheets and good documentation don't tend to struggle with that very much. But we see customers that have had turnover, or they've had contractors do work or something like that, and they might not have the best documentation, and that's normally where we see the hurdle. It's like just finding all the information about the app. Once they find it, the Habitat pieces are relatively trivial. They're written in OS native languages. So for Windows, they're PowerShell, and for Linux, they're Bash. So most folks that deal with those operating systems tend to at least have some familiarity with that. So you don't have to go learn another language to use it.
Another one here, do you have core plans for Ruby on Rails applications?
Yeah, there's core plans for Ruby, and there's scaffolding for Rails applications that is out there. I believe we've got, I don't remember if it's on the Have website or if it's in Learn Chef, but I believe we've got some basic tutorials on Rails.
All right, well, I think we will close out there, give everybody a few minutes back in their day. So again, just a reminder, this is recorded, so you'll be able to watch again if you so wish. And a reminder as well to register for ChefConf if you haven't already. chefconf.io, happening June 2nd and 3rd. There's a ton of great content that's being created. There's also a bunch of session recordings that we're doing leading up. And this week is actually on Chef Habitat. So go to our blog, and we have quite a few sessions still being recorded. I believe we have some today and through the end of the week. So be sure to check that out if you haven't already. And with that, I will close it out here. Thanks everybody for attending, and have a wonderful rest of your day.
Cool. See y'all.
Thank you.